Class, welcome to the lecture on Chapter 6, Section 6.1, Systems of Equations in Two Variables. Sorry I didn't make it to class today, and hopefully this will provide you with what you need for this material, and I'll see you on Thursday. So we're going to be solving systems of two linear equations with different methods, and then looking at some problems. So a system of equations is just when you have more than one equation and that they're linked, and so you're trying to find a solution that solves both of the equations. And so in this example that you're seeing here, we have 5x minus y equals 5 and 4x minus y equals 3. We're trying to see if there is a solution, an x value and a y value, that when plugged into both of these equations will make them both true. So instead of just finding, typically if we have one equation, then we can graph that by plugging in an x value and finding out the y value in both of these. And that is one way to solve systems of equations, is graphing them and then looking where they intersect. Okay. This is a system of two linear equations in two variables. The solution set of this system consists of all ordered pairs that make both equations equal. So if we're talking about a system, we have to find an x and a y value that make both of these statements true. In this case, if we look at the ordered pair 2, 5, where x is 2 and y is 5, this is true. If you plug those values in for each of the equations, you'll see that that works. When we graph a system of linear equations, each point at which the graphs intersects is a solution of both equations, and therefore a solution of the system. Okay, so if we graph these, they're very closely aligned here. You can see the point where they overlap is at x equals 2, y equals 5. And so this is a visual representation of a system of equations. So we could even have more equations. We could have 3 equations, etc., and we'd be looking for that point, if there is such a point, where they all intersect. Okay, so let's see how we do this. Okay, we already know the solutions to these, but we're going to try to do these. We're going to use the same example in different ways. Normally, this would be an activity that we would do in class in your groups. So we have 2 equations, and we're going to solve these using this substitution method. The first thing you need to do is to rewrite one equation. I want you to rewrite this equation, solving this equation for y. What does that mean? Rewriting it, solving for y. That means that I want this to be rewritten so that you have y equals, y is on itself is on the side by itself, and everything else is on the other side. So the first thing we want to do is probably subtract 5x. Actually, I did the opposite. I like to get the y positive. So if I add y to both sides, we get 5x equals 5 plus y. Again, I want y to be by itself, so now I need to subtract 5 from both sides. And now I have solved this original equation for y. Y equals 5x minus 5. Okay? The second step is I need to plug in the formula 5x minus 5 wherever I see y in the other equation. So now remember, we know what the other equation is, 4x minus y, but we know that y equals 5x minus 5, so we're going to plug in this part of the formula in parentheses, and then we're going to simplify. Make sure you plug in the formula in parentheses, especially if there's a minus, because that changes the sign. 4x minus a positive 5x is minus 5x, minus a minus 5 is plus 5. 4x minus 5x is negative x plus 5. If I subtract 5 from both sides, I get 3 minus 5 is negative 2. And if I multiply both sides by -1, now I get the x value. X equals 2. At this point, now I can plug this into either equation and find the y value. So if I plug it into the first equation, I get 5 times 2, x equals 2, minus y equals 5. 10 minus y equals 5. If I subtract 10 from both sides, I get negative y equals negative 5. So multiplying by -1, I get y equals 5. Plug it into the second one, I get 4 times 2 minus y equals 3. This gives me 8 minus y equals 3. Subtract 8 from both sides, I get negative y equals negative 5. Multiplying both sides by -1, I get y equals 5. These should be the same. I just wanted you to show you that you could plug it into either equation and it would work out. And of course, that's the value that we found by graphing previously, that the intersection or the system solution is the coordinate 2, 5. X equals 2, y equals 5. Now, we're also going to look at a different method for solving these. This is called the elimination method, okay? And what we're trying to do here is get opposite numbers in front of one variable. So notice right now we have, when I say opposite numbers, I'm talking like, for example, if there was a 4 in front of the x in one equation and a -4 in front of the other one. And I'll explain why in a minute. So we look at this equation and we see, is there any easy way to set this up? Well, there's a -1 in front of y on both cases. Well, we need them to be opposites, so one of them has to be positive. Remember, as long as I multiply both sides of an equation by the same number, then I'm not changing the equation, it's still true. So if I multiply one of these equations by -1, then I will have opposite numbers in front of the y term. So I'm going to take the top equation, I'm going to multiply it by -1, and so I get -5x minus, or excuse me, -5x plus y equals -5. Do you see how I've changed that equation? All I did was multiply the entire first equation by -1. It's still true. Now, why did I do that? Well, as soon as we have opposite numbers in front of one of the variables, we can add the two equations, the x values, the y's, and the constants. And notice what happens is we eliminate one variable. So -5x plus 4x is -x, -1y, positive 1y plus -1y gives us 0y, so they disappear, they are eliminated, and -5 plus 3 is -2. And again, we can multiply both sides by -1, and we get the answer x equals 2. And of course, we just plug that in, which we've already seen. I'm not going to go through that, and we have the same answer. Okay? So again, when we're doing elimination, what we're trying to do is get a positive and negative number of opposite numbers. So if there's a, here we have -1 and -1, we need a -1 and a +1. Okay. So let's look at that same equation, but let's say we want to eliminate the x's instead of the y's. How can we do this? This one was actually easy to do because there was the same number, but they were the same polarity. They were both negative, so we just multiplied one by -1. But what if we wanted to get rid of the x's? This looks a lot more complicated because they're different numbers. It's actually, there's a simple way of doing this, and that is take the coefficient on each value of x. So like the first equation has 5, the second equation has 4, and take the multiplier on x, the coefficient on x, and multiply it times the second equation. In the second equation, the multiplier on x, or the coefficient, is 4, and we're going to multiply the first equation. Notice what we did. We just took we're trying to get rid of the x's. We took the 4 to times the 5, and the 5 to times the 4. Now, that will give us 20x, but notice they're both going to be positive. So we need to make one of these negative so that they will cancel out. So really what we have here, we could have picked either one. We actually multiplied the second equation by -5 on both sides. -5 times 4x is -20x. -5 times -y is plus 5y. And -5 times 3 is -15. So all you have to do is put the multipliers, switch them, whatever's in front of the top x, put it on the times the second equation, make sure you do it on both sides, etc. So you just flip the coefficients and multiply the whole equation, and then make sure one's positive and one's negative. In this case, they were both positive, so we made the second equation be negative. Now we add the two equations, and we can see the x's are going to disappear, and we just get y equals 5. Now we can plug this into each of the equations, and we get x equals 2, once again solving it. So this elimination method is pretty simple, even when there are numbers that aren't really the same to begin with. Just again, take the multipliers and cross multiply them, sort of like 5 times the second equation and 4 times the first to get rid of the x's. If a system of equations has at least one solution, it is called consistent. If it has no solutions, it's inconsistent. Now, how would two lines not have a solution? They would be parallel, okay? So where they do not intersect at all, okay? So if a system has no solutions in two variables, these are parallel lines. If a system of two linear equations in two variables has an infinite number of solutions, we call these equations dependent. And the only way this is going to happen is if they are literally the same line. Otherwise, they are. So here we can see cases of exactly one point in common, one intersection. This has a solution just like the examples we've been looking at where it was 2, 5. This is a consistent because it has a solution, and it's independent because it has just one. Parallel lines do not intersect anywhere, so there is no solution. There are no common points, and so this is inconsistent because there's no solution and it's independent. Here you can't actually see it, but the idea here is that one line is on top of the other. The lines are identical, and so they have an infinite number of common points. Whatever point is on one line is on the other, and there's infinitely many solutions. So this is consistent because it has a solution, but it's dependent because they are actually the same line. All right, so let's look at an example of how this works out. Ethan and Ian are twins. They've decided to save all the money they earn at their part-time jobs to buy a car to share at college. One week, Ethan worked 8 hours and Ian worked 14 hours, and together they earned $256. The next week, Ethan worked 12 hours and Ian worked 16 hours, and they earned $324. How much does each twin make per hour? Okay. When you're dealing with word problems, the first thing you want to do is assign variables. Okay. And the variables represent what we're looking for. And so here we're looking for what does Ethan make per hour and what does Ian make per hour. And so I'm going to pick variables E for Ethan and I for Ivan. E is Ethan's pay rate and I is Ian's pay rate. Okay. So note that on 1 week, Ethan worked 8 hours. So how much did he get paid? 8 times his hourly pay rate, 8E. And Ian worked 14 hours. So how much did he get paid? 14 times I, because that's his hourly rate. So 8E plus 14I equals 256. Okay. We do the second thing for the second equation. 12E plus 16I equals 324. Now we have a system of equations that we can solve using elimination. Okay, so in both of these cases, I have really large numbers. I can just swap out the 12 and the 8. So I'm going to multiply the first equation by 12, the second equation by 8. So multiplying the first equation by 12, 12 times 8 is 96, 12 times 14 is 168, and 12 times 256 is 3072. I need to multiply the second equation by negative 8 because I need them to be opposite signs. 8 times 12 again is negative 96. Negative 8 times 16 is negative 128. And negative 8 times 324 is negative 2,592. Remember, now I just add the equations, the e's drop off, and I'm left with 40i equals 480. Dividing by 4, I get Ian's pay rate is $12 an hour. I can plug this into either equation to find out what Ethan makes. And I get that Ethan makes, if I use the first equation, I get that Ethan makes $11. Okay. So look at this one. We're going to try to solve this one. This is just a tricky example is what I call it. If we multiply the first equation by negative 2, notice we get negative 2x, so we can cancel those out with the second equation. When we add them, the x's cancel out, and also the y's cancel out, and so I get 0 equals 21. When the variables disappear and I have a false statement, this means that there is no solutions. There are no values of x and y in which 0 will equal 21. So this system has no solution, meaning these two lines are parallel. Again, when the variables disappear and the equation is false, there is no solution. The graphs of the equations are of parallel. Let's look at another tricky example. Notice if I multiply the second equation by negative 3, I'm going to have 9x, negative 9x in the bottom. So now I can see that my x's are going to cancel out. But here when I do this, the y's also cancel out, but the other side of the equal sign also cancels out to 0. 48 minus 48 is 0. Okay. Notice that this first equation is just a multiple of 3 times the second equation. So technically, they are the same equation. If I divided each term by 3 in equation 1, I would get the second equation. These actually are the same equation. When all the variables disappear, but we have something that is true, 0 equals 0, we call this a dependent system, and there are infinitely many solutions. They're actually the same line. So when the variables disappear and the equation left, 0 equals 0 is true, there are infinite number of solutions because they are the same. All right. So systems of equations are quite common in business and other places, and mixture problems is one example of this. When a business is creating a mixture of products, they're trying to figure out how much to charge, etc. All right. So let's look at this problem. At Max's Munchies, caramel corn is worth $2.50 a pound, is mixed with honey roasted nuts, worth $7.50 per pound. Sorry. In order to get, I'm so sorry, a 20-pound mixture worth $4.50 per pound. How many pounds of each snack is used? This can be a really confusing problem. So building a table makes this much easier. So we have caramel corn, we have nuts, and we have a mixture. And we want to know the cost per pound of caramel corn, the nuts, and the mixture, the number of pounds of each that we need to use, and then we can figure out the value of the mixture. Okay? Now remember, our variables answer the questions. So we're asking how many pounds of each snack is used. So how many pounds of caramel corn? That's going to go here. We'll make that C. And how many pounds of nuts? We'll make that N. Okay, those will be our two variables. What's the price per pound of caramel corn? It's all in the problem, $2.50. How many pounds? Remember, we made that the variable because we're trying to figure that out, C. So what's the value? The number of pounds times the price per pound is the last value. Nuts, price per pound, $7.50. How many pounds of nuts are we? That's our variable because we're trying to figure that out, N. And then the value would be multiplied, right? If we have N pounds of nuts at $7.50, if we had 2 pounds, it would be $15, etc. So what is the mixture? The price per pound? We want the mixture to have a cost of $4.50 a pound, so that's also plugged in. How many pounds of each snack? The number of pounds, we know that we want to create a 20-pound mixture, so that's what goes here. And the value of the mixture, we're just going to multiply those, which is 20 pounds times $4.50. Okay? So filling in this chart can make it a lot easier. Remember, if we have this C pounds of caramel corn times $2.50 a pound, this gives us the value of that. Okay? All right. The number, we know that we're going to mix caramel corn and nuts to create 20 pounds. So C plus N is going to equal 20. That's our first equation. And we know that the value of the caramel corn is $2.50. So $2.50C plus $7.50N is going to equal the value of the mixture. So that gives us our two formulas. One is for the total amount. C is the number of pounds of caramel corn, N is the number of pounds of nuts. The total value is that product again, 250C plus 750N, and that's going to equal what we have at the end, which was actually a number 90. So here all we have to do is we can multiply the top equation by negative 250 to solve this system. So notice, instead of, like, this might be something you want to do, and I like doing this before we move on. Instead of $2.50 times C plus 7.5 times N equals 90, if we multiply everything by 10, we drop all the decimal places, which often can get a little confusing in these complicated problems. So just multiplying that whole equation by 10 got rid of the decimal place, and now it's a little bit easier to see. So if we multiply the top equation by negative 25, we get negative 25C minus 25N equals negative 500. If we add that to the second equation, doing the elimination, notice that the caramel corn, the C variable, disappears, and we're left with 50N equals 400, or N equals 8. So we have 8 pounds of nuts, and we know that the total pounds is going to be 20. So we just plug that in, and we get 12 pounds of caramel corn. All right. So when you're dealing with mixtures, each of your things that you're mixing or the column headings, usually there's a cost for them. Again, remember always your variables are based upon what the question is. Your variables is based on what the question is. So in this case, C is the number of pounds of caramel corn, N is the number of pounds of nuts. All right. These are really whacked out problems, okay? These are a challenge as well, but again, they help with if you build a table. If you've ever rowed a canoe or something and you're going with the stream versus against the stream, if you're going with the stream, notice that the water is pushing you. So while you may be rowing, let's say 4 miles per hour, maybe the river is pushing you an extra mile per hour, so you're actually going 5 miles per hour. If you're doing this in reverse, you're rowing at 5 miles per hour, but you're going upstream and it's pushing you back 1 mile an hour, then you're only going 4 miles per hour. And so that's what this idea is. And when you have these problems, they can be airplanes and air pressure or wind force. You know, again, if you've ever ridden a bicycle into the wind or with your back to the wind where it's pushing you, it's a big difference. Okay, so let's look at this. The airplane flies 3,000-mile distance from LA to New York with a tailwind. So it's pushing the plane. It's pushing the plane. A tailwind means it's pushing you. It's a headwind is when it's against you. In 5 hours. The return trip against the wind takes 6 hours. Find the speed of the airplane and the speed of the wind. Okay, remember, first thing we do is assign variables. In this case, I'm going to have A is the speed of the airplane. Actually, I'm going to have P is the speed of the plane, and W is the speed of the wind. All right. So notice when we're going from LA to New York, what is the speed of the plane? The speed of the plane, because it's got a tailwind, is going to be the speed of the plane plus the speed of the wind. Right? Because it's pushing you, you're going faster. When you're coming back, right? When you're coming back, you're going to subtract the speed of the wind because you're, you know, again, you're facing the wind, so it's making you go slower. Okay. So a table can be really helpful here. So we know the distance is both 3,000. The rate of the plane when it's with the tail, because they fly from LA to New York and back, so it's the same distance. Tells us it's 300,000 miles. The rate, when we're flying there, it only takes us 5 hours, and that's P plus W and 5. And when we're facing the headwind, it's P minus W. Now remember, distance equals rate times time. Distance equals rate times time. Speed limit, right? So we get 3,000 equals 5P plus 5W. Oh, that's actually smarter. I was going to multiply these out, but notice if we divide the left side of the equation by 5 and the second equation by 6, we automatically had this set up to do elimination. Very clever. We could have done it anyway, but instead of multiplying this out, dividing both sides by 5 does not change the equation. And so now when we add these equations, we get 1100 equals 2P, right? 1100, when you add these, you get 1100 equals 2P. So 1100 divided by 2 gives us the speed of the plane, 550. And we know that the speed of the plane plus the wind equals 600, so the speed of the wind is 50. All right, I hope this has helped, and this is all the material that I was intending to cover today. Again, I'm sorry. I was teaching my trade class this morning, and I just couldn't get, I kept losing my place. Hopefully, this will suffice for you guys. Again, sorry I'm missing lecture today.